Hello, I am Sînică Alboaie, and I will briefly explain the vision behind AssistOS. The original idea behind AssistOS started from a simple observation. When large language models became mainstream in 2023, it became clear that AI would make computers easier to use for almost everyone. At the same time, it also became clear that we had a serious opportunity to redesign user interfaces and user experience. The goal was not to impose more discipline on users, but to hide the complexity behind a strong AI-assisted layer. My intuition was that professionals, researchers, creators, and eventually ordinary users could work with computers in a way similar to how software engineers work with an IDE. Programmers already use structured workflows, source control, clean processes, specifications, and specialized tools. In science, software, research, and many domains where generative AI becomes a co-creator and co-worker, this kind of rigor becomes necessary. However, users need support from the operating system, or at least from a control layer above the operating system. This is how the idea of AssistOS emerged. AssistOS provides a visual interface for working with files, documents, repositories, creative pipelines that use AI and structured knowledge. It must support complex editors and viewers as custom plugins, but it also has a powerful co-pilot integrated by design. Most actions should be possible through natural language requests using either text or voice. Axiologic started the first AssistOS experiments in 2023 and continued them more seriously in 2024. These experiments gave us the first architectural insights and helped us prepare a research funding proposal. This later contributed to our participation in Achilles, a European Union-funded research project that allowed us to explore these ideas in a more disciplined and substantial way. The main AssistOS interface looks like a simple file explorer combined with different editors. However, under the surface, it connects the user to AI systems, strong data management tools, version control, and team collaboration. In this sense, AssistOS behaves like an IDE, but for broader forms of knowledge work. One of our key research directions was the management of specifications. This is essential for AI research, software development, and complex professional work. Markdown files became especially important in our experiments because they are simple, readable, and easy to connect with tools and AI workflows. We tested specialized Markdown editors that help manage build processes, tools, and agentic pipelines. To support this work more rigorously, we created our own language, called SOP-Lang. We now use SOP-Lang in our internal agentic setups. It is one of the most important and innovative results of the Achilles project. The central idea is simple. Generative AI is changing how we use computers. In the future, many users will work inside new kinds of IDEs, even if these tools will not be called IDS. These environments will reduce the need for complex menus and traditional interfaces while still making version control, collaboration, and structured work easier. The Axiologic team already uses GitHub integration inside AssistOS every day. We also call this environment Achilles OMDE. It allows us to manage many Git repositories in one workspace and quickly synchronize local files with Git. Coding agents advanced rapidly in 2025. At first, they mainly helped with code completion. Later, CLI agents changed the workflow more fundamentally. With a good agent, users no longer need to search, open, and edit files manually in the same way. IDEs increasingly become environments for reviewing, controlling, and validating what agents do. Coding agents understand text commands, plan complex changes, and execute them on request. We believe this interaction model will become normal not only for programmers, but also for researchers and everyday users. In a sense, it resembles the way people imagined computers in science fiction. The user asks the system to do something, and the system executes the task inside a controlled environment. This is why we call AssistOS an operating system. It is our plan to bring Achilles, the Fire DE, to the market as an open source platform, with specialized enterprise editions for advanced configurations. We also wanted to explore human and AI teamwork. AssistOS includes a classic chat interface called Web Chat Copilot, but we wanted to go deeper. We built an internal tool called WebMeet directly inside the IDE. The Axiologic team already uses it for daily meetings. WebMeet can replace tools such as Teams or Zoom for certain workflows. The most important WebMeet feature is called RoboTeam. It allows a team to control an AI copilot together. We are still exploring this direction, but the vision is clear. AI can bring multiple virtual participants into a meeting, each with a different role, expertise, focus, or position. These agents can debate, teach, help with decisions, simulate stakeholders, or even participate in theatrical and educational formats. In the future, such AI participants could work side by side with humans on the same files, documents, repositories, and projects. One stable RoboTeam could become an important step forward in human-AI collaboration. AI models are changing how we do research and how we work with computers. Coding agents are already mainstream, but there is still a large space for real innovation. In the past, code was often the most important asset. Today, specifications, research processes, workflows, and validation procedures are becoming equally important, and sometimes even more important. We need new tools to manage and execute these processes together with AI. This is the purpose of Achilles on DE. It provides the classic capabilities expected from an IDE, but it is designed specifically for AI agents. Our system is cloud-ready and uses a secure deployment environment called Ploinky. Ploinky helps us run AI agents safely inside closed sandboxes. What makes us different is also our focus on trustworthy AI. The Achilles project places trust, reliability, and controlled execution at the foundation of the system. Our white paper and website provide more details about the agents we are building and the open source technologies that make AssistOS possible. The reason for building Achilles on DE should now be clear. Achilles IDE is already a working tool. The Axiologic team uses it every day, and the main architecture and roadmap are clearly defined. The system grows step by step through the agentic skills we create. Coding agents already help us package software components and build IDE plugins, which allows us to integrate new use cases faster. We have developed strong insights into how agentic skills should be designed. We are now researching what we call knowledge units, which generalize agentic skills and provide a foundation for the meta-rational pragmatic virtual machine. This is a new way to think about agentic architectures, and it will be discussed in more detail in the following slides. Generative AI taught us an important lesson. Raw code is no longer the only primary intellectual asset. High-quality specifications are becoming the central asset. These specifications guide our research, engineering, validation, and development processes. We also identified two major risks. The first risk is the rising cost of powerful AI models. This is likely to continue. Our answer is to use smaller local models where possible and orchestrate them intelligently to obtain high-quality results. This reduces dependence on expensive external services. The second risk is a possible AI bubble burst. Some people may reject AI because of fear, disappointment, or unrealistic expectations. This could slow market adoption. However, our research points toward a different long-term future. We believe AI will gradually be absorbed into ordinary software. It will become a normal, quiet, and trusted part of the tools people use every day. It will not always appear as a separate, frightening, or autonomous entity. In many cases, it will simply become an invisible layer inside software. On the technology and research side, confronting the limits of standard React patterns and current tool use, specifically bloated contexts, high API costs, repetitive output, hallucinations, internal logical inconsistencies during long text generation, failure to follow complex specifications, and lost in the middle problems, pushed us toward a fresh theoretical and philosophical model for how AI agents should use natural language interpretation. This insight allowed us to engineer new architectures. By shifting from simple text completion to a dedicated virtual machine layer, we established the structured environment necessary to reliably build next-generation enterprise agents. Let me explain a little more about what we do under the hood to build agents that are cheaper, easier to use, more generic, and more trustworthy. Our experiments in Achilles use cases and commercial projects revealed serious limitations in standard React patterns and current tool use approaches. Standard agentic systems often create problems for both trust and user experience. They can suffer from high latency, unstable responses, bloated context windows, high API costs, repetitive outputs, hallucinations, and internal logical inconsistencies during long text generation. They also frequently fail to follow complex specifications and are strongly affected by the lost in the middle problem. where important instructions are ignored or forgotten. These problems pushed us toward a new theoretical and engineering model. We designed Achilles Copilot as an orchestrator of specialized agents. The most important part of our AssistOS research concerns agentic skills. We developed new types of skills that differ substantially from the standardized agentic skills used by mainstream coding agents. Recently, we unified these insights under the concept of the Meta-Rational Pragmatic Virtual Machine, or MRP-VM. This will probably become one of the main centers of our future research. We started from a clear limitation. Current agents usually rely on the React pattern. This pattern is general and powerful, but it has major efficiency problems. The context grows too quickly, hallucination risk increases, and trust in the final result decreases. Our current work with Achilles Agent Lib improves trust and efficiency, but it still requires significant manual setup. Explicit context control remains difficult. The meta-rational pragmatic virtual machine aims to provide a better balance. The main innovation is the way we build skills. We treat them as independent building blocks that combine contextual knowledge with the ability to interpret executable structures. They behave like Lego bricks. Agentic solutions can be built by connecting these blocks through natural language and structured execution. This approach is efficient in many situations, although sometimes it can create too many requests to language models and increase orchestration complexity. The general direction remains clear. We treat AI solutions like classical software architectures. Predictable control is the main goal. Instead of relying only on bigger and more expensive models, we make precise local adjustments, improve efficiency, increase trust, and reduce costs. During the years in which we focused on AssistOS, we developed a clear and opinionated perspective on how future AI operating systems should be architected. Our research includes consistency, bias, explainability, tool usage, planning, agentic execution, and the broader MRP-VM direction. Beyond these topics, we developed several insights that distinguish our work from mainstream industry approaches. One of these insights concerns meta-rational pragmatics. Another concerns SOP-Lang, which can replace many JSON-based and ad hoc protocols in agentic harnesses. SOP-Lang allows a more structured form of agentic reasoning. It can represent multiple possible execution paths, variables with several possible values, plans that can be analyzed, and structures that can be connected to theorem proving or abstract interpretation. In practice, we created a dedicated virtual machine layer above SOP-Lang. This structured environment helps us build next-generation enterprise agents more reliably. SOP-Lang is the core of this solution, while the architecture around it behaves like a virtual machine designed for SOP-Lang execution. This enables what we call meta-rational execution. In regular software, a variable usually holds one value. In our system, a variable can represent multiple possible values, and the system can explore multiple execution plans at the same time. The system can evaluate its own work, generate demonstrations or proofs for important steps, compare alternatives, and select the most appropriate solution according to explicit criteria. This method increases the epistemic value of the output. It helps us move toward AI systems that can be trusted in scientific research, enterprise processes, and highly regulated industries. We are confident that our theoretical innovations, combined with solid implementations developed through the European Achilles project, can help us build a realistic and fair future for AI. Privacy support, native deployment for local LLM models, and a dual cloud/local architecture give us confidence in the future adoption of our work. Thank you for your attention. If you are interested in contributing to the open source AssistOS ecosystem, please contact us through the contact page. AssistOS is simple to install and use. It allows users to run local LLM models, expose them through a centralized interface, add their own keys and providers, and observe model traffic. This makes it useful very quickly for working with Git repositories, local models, cloud models, and the AI agents users want to build. AssistOS is our attempt to make AI-assisted work more structured, more trustworthy, and more accessible. It brings together files, repositories, specifications, agents, local models, cloud models, collaboration tools, and controlled execution into one coherent environment.